of a perpendicular bisector. Visually, that looks like we got these 2 points, P and Q here. Let's say this is P, this is Q, this is just a sketch. And the perpendicular bisector is something that goes right through the middle, a line that goes right through the middle of it and is at right angles. So it has the complete opposite gradient to the original. So we need to get the gradient of the original, which we call m, of course. We should have that formula y2 minus y1. So let's use that. Negative 6 is y2, minus 2, and then 5 minus a minus 3. So that's plus. So it's negative 8 over 8, which is negative 1, isn't it? So that's my gradient of this line. But of course, I want the perpendicular gradient, so the perpendicular gradient would just be 1, wouldn't it? All right, we should know that the perpendicular gradient is 1 then. Okay, so that's my gradient. 1 is the gradient of this line, but I don't know this bisector part, so the bit where it cuts it perfectly in two. That means I need my midpoint. Midpoint, I can use my formula, or I can just logic it out. What's halfway between minus 1 or minus 3 and 5? I think it would be positive 1. And halfway between 2 and negative 6. Negative 2, I think. You can use the formula where you add them up and divide by 2 as well. So minus 3 plus 5 and then divide by 2. But I think logicking it out gets us there pretty fast. And then, so this is question 6. And then I like to use this formula. You could use y is mx plus b. You should get the same result. Easy to sub in these 2 points. This is y1, so plus 2. My gradient, so remember I'm getting this line now, the second line. My gradient is now 1, x minus 1. I'm happy with that. I'm not very happy with that. You probably should tidy that up a bit. Multiplying by 1 is not a great idea. I know I'm going very sideways here. X minus 1 multiplying by 1. And maybe even put it in this form. I'll accept all these. They're fine. So give yourself 2 points for that if you got it fully correct. If you got the gradient correct, give yourself 1 point. Fully correct for 2 points for that. Question 6. Let's look at question 7. So we have x minus 5y plus 6 is equal to 0. And we're looking to get the gradient. The gradient of this line. So the gradient of this line is, well, we have to rearrange. We need y is mx plus c. So I can start by maybe, let's have the x over here and the 6 over there to get in the right arrangement. I think dividing by minus 5 should get me where I want to be. So that'd be plus 1/5 here and plus 6 over 5 here. So I can read the gradient then. This is the gradient. And the gradient is 1/5. So that's the first part of the answer. So give yourself a point for that, for the gradient of the line segment. And the gradient of the perpendicular bisector is, what is it? Negative 5. Flip it upside down, change the sign. Okay. And that's the second answer. Okay, that was it? Oh no, state the equation of the perpendicular bisector. We already know the midpoint. That's very handy. So it's just back to the thing we did before. Y minus y1, which is, what was it, 4,2? Sorry for moving, 4,2. 4,2 is my point. So y minus 2, the gradient is minus 5 now, x minus 4, and then maybe just tidy it up by multiplying out the brackets. I'll accept this if you've written that. Minus 5x plus 20. I do like to then at least finish off, add the 2 on this side, plus 22, because at least then, if it's a further question, you'd know what the y-intercept was. I'll accept all of those, so give yourself another point for that. Come back up here. So far, 2 points for that, 2 points for those two, and another point for the equation of the lines, so 5 in total. And now we have scientific notation, which should be hopefully a quick review. To turn this into scientific notation, you got to move this decimal place 5 points. We need to sit it in here, don't we? In between the 7 and the 2. So that'll be 7.25 by 10 to that. And we moved it 5 spots to the 5. So that's that answer for a point. Oh, so yes, of course, I moved it 5 points in the small direction. So negative 5, my bad. And this one then, we have a 6 power here, so I move the decimal point 6 spots. So 1, 2, 3, 4, 5, 6. Fill in those 6 with zeros. So I should have 4 zeros at the end of my number. So that's 4,830,000 as your number. So another point for that. So 1 for this, 1 for this. And the last one, we have to do some solving by elimination. It said if you solved it using substitution, which I wouldn't recommend, yeah, that's fine as well. So let's have a look at this one. Do I have enough space? Not really. 3x plus 2y is equal to 8. And 5x minus 4y. Okay. My strategy here is I'm going to cancel out the y's, so I'm going to multiply by 2 the first line maybe, and the y's should cancel out. So I'll multiply, you can call line A, line B, and then multiply A by 2 if you want to tidy up your working out. That's 6x doubling this line plus 4y is equal to 16. And we have 5x still. I haven't changed that second line at all. That cancels out. Add down, I have 11 x's. 33, x is 3. That's half my answer. The second half, if I sub in, I'm going to pop it into this. I should have an answer for y. I think that gives 9. What is it, minus a half? If I get minus 1 over here, so that's 9. 8, take away that 9 gives minus 1, so y is negative a half. Both solutions, a point each for both solutions. Okay, so